Hi, welcome to another power supply tutorial video. In this video I'm pretty much wrapping the main design off. I have a prototype set up and working, which I'll be showing you very shortly, and also I'll be going through how to do the calibrations on this system. The information is going to be a bit sketchy because it's not all been finalized and made nicely for everyone yet, but it's a work in progress, and the information will be available on my website 39k.ca, and you just look under this video's post and it'll be all there. But yeah, after this video we'll be going on to tweaks and add-ons pretty much, and changing different configurations, and hopefully in January I'll have finalised the design, and boards will be available if anyone's interested in doing them. You can download the Gerbers or the schematics or whatever from my website when they become available, or you can buy them through me, which I will, if there's enough demand, I will start selling them and probably sell them as kits as well. But yeah, so without further ado, let's go straight to the bench. Okay, there it is, all in its glory. I'll quickly explain what's going on here. Right now it's hooked up to the computer. Ideally I'd want this near the end of the case, but this is just together for the prototyping. Okay, that's the LCD cable. Got the contrast on there. As you can see, it's the same board as before. I've added the analog circuitry. This is a direct 1-for-1 transfer from the breadboard. This here goes off to the pots on the front. This to the buttons, although we're only using one right now in this circuit. I put an expansion port on here. I did have a pinout for it around, but anyway, I'll show you that on the circuit diagram in a bit. Okay, so I got a 12-volt supply going to the fan, although it seems to be running off the Arduino. I don't know why, but anyway, it shouldn't be doing that. And yeah, so I put these connectors in to connect to the transistor, which I've remounted. This time now it's fully isolated from the case. I was a bit worried about that because previously the screws cut in through the nylon washers and kind of shorted it to the case. It would have worked, but I just wasn't happy with it. Okay, now these 4 wires here go off to the front banana plugs. One for power sense, one for ground, and one for ground feedback or whatever. And then obviously I got my shunt. I didn't get the shunts in yet. Now what we have here is, this is from my rectification and regulation board. What we got is got 5 volts, 12 volts, actually 11.5 in this case, and then we've got the ground. Oh sorry, 12 volts, the 5 volts, the 11.5 volts, and I also have the 28 volts as well coming off, as well as ground. 28 volts go straight up to here. And there's the regulation board. Now, it's what comes out of here is like 11.5 volts after the rectification, and then I tap that off for the op amp supply, and then I regulate it with a 7805 to get the 5 volts for the logic. And over here we have the 28 or whatever volt winding coming off, and that is the main voltage for regulation. Unfortunately, this is the only transformer I had handy to do this with, and it's a little underpowered, so I'm only getting like 250 milliamp right now, maximum, which is perfect for my testing purposes right now. You know, makes it a little harder to test and calibrate the current regulation and settings, but it's enough to get the voltage done. But I will be probably putting in an extra voltage somewhere else from somewhere else for the regulation with a bit more current on it. That'll be in a supplemental one. But for this one, we're just going to concentrate on the calibration. As you can see, I've got my stuff all set up ready for calibrating. This meter's reading the current through that. I should probably I'm going to stick it on a little bit more sensitive reading. Not that good of a meter, unfortunately. And this one's reading the voltage. Okay, so I know the screen's on right now. That's because it's the Arduino's powered by the computer. But I'll turn this on, and now we actually have our thing up and running. Okay, where's the 4 milliamps flowing through that? Alright. Okay, so let's see, we've got the set as 24.95 volts and 25.4.2, so the calibration's a little off. I did pre-calibrate this, but it's not the greatest. On the left is all the settings, what's set, voltage and current limit, and on the right is what it's reading back. I need to, do a bit more stability with the readings, but it's a work in progress. So let's change things over here. Change the voltage down. Let's see what get close to 10 volts. There we go. There. 10 volts, 11.36. So, it's a little off. And I'll show you. I'll crank the current up as far as it can go. It is telling me it's getting like 300. Oh, that's why that's not reading right. There we go. So yeah, see, 250 milliamp is what I'm getting maximum on there, and the feedback's like all over the place, so not quite. But you can see the voltage has dropped dramatically, unfortunately. Yeah, I need to redesign this thing as well. The code's a bit blur. Alright, let's drop that down. You can see the voltage rising back up as the current's dropping. I did actually take this to the college yesterday to calibrate it nicely on their pre-calibrated equipment, but I forgot to take my USB cable, so I couldn't do that. Okay, now I've added a mode on this. If I hold this button down, it shows me the raw ADC count, which is what's needed for the calibrations. So let's get to that. Okay, on my screen now I have the schematic diagram. I'll quickly talk about that before we go on to the calibrations. Okay. This is just a rough one. I'm going to be tidying it up soon. But we've got this dual op-amp package here for the regulation, and this one for the buffering, so straight to the ADC from the readings, so it doesn't interfere with it. I got the voltage reference here to go along with the ADC. There's the DAC, there's where the Arduino is, and there's where the button inputs. But they might move to just a more generic type connections in the final design, but it's there we go. Now this schematics will be available on my website. It should be available right now. I intend to put it up as I put this video up. And we've got the voltage inputs, but like I said, this is a work in progress, so it will change before the final or the first revision for the PCB. I've shown the LCD on here, but like I said, it will be just coming out to some headers, so you can wire it up to that type of screen or a graphics screen or even an LED display, depending on how you want to do it. This is an open source project. And the software does need a bit of work, so I'm just building the basic platform to work off. Okay, so in order to calibrate, what we need is a spreadsheet up. So basically, what you want to do is you want a column with the voltage you're going to read on the meter. Try and use the most accurate meters you can find. And then you need a raw count, and so what I'm going to do right now is I'll show you the first one, then I'll go ahead and do it off camera. Right, what I've done is I've done the numbers again. For some reason it crashed and I had to redo them, but anyway, these are the voltages and these are the counts. Now basically what I've done is I've told it that I wanted to divide this number by the count, and this here gives me the number of volts per count. And as you can see, the number does vary a little bit. It seems to go down higher you get, so it's not quite linear, but should hopefully find a way around it. But it's pretty okay, you know, stable. But anyway, what I did is at the bottom I have taken an average of the count, and it's like 6.565 millivolts per count. And then basically, bloody thing. What you do is you basically copy this number, and you can put it on the sorry for bad cameramanship here. You put it here on the calibration for the V out, and then you just compile it and send it over to the Arduino, and we'll have a look, see how accurate that is. Okay, what is, I just pulled it out and stuck it on the USB and uploaded it directly. Okay, so let's pick a voltage, say 12.49. You can see I'm still about 20 millivolts out. It's a work in progress, and 26.88, 25.2. As you see there, I've only got like 8 points I've done, but for a proper calibration, I would say you need at least 20 or 30 points. When I used to do this in my old job, we used to do like 40 of them, and very tedious. We had to sit there with a test meter and measure each point as we were doing it. But that is how you calibrate anyway with these. And like I said, this is a work in progress, so it needs the odd tweaking here and there. But all in all, it is basically a done unit. The software needs a bit of work doing to it, of course, as well as some of the smoothing of the signals, filtering to be done. And I still need to finish the teardown of the other satellite receiver, and that way we can build a companion unit to sit on top, and I can start working on the CAN bus communication between the two, and that will be part of the supplemental as well, because I haven't installed the CAN bus circuitry on this yet. I do have it, I just haven't put it in. That'll go on the, probably fit this on the expansion on here, but it will be available on the main board as an optional population if you want it or not. But yeah, I hope this information is useful in this video. If you want any more information, just comment in the comments section, let me know, and I'll try and answer your questions. But out of breath now. The schematic will be available on my website, 39k.ca. You just look at this video's post, and there should be a link there for you to download it, as well as the Arduino code. It is in a bit of a state right now, but I'm also going to put together a little flowchart stating how the software is operating right now. But basically, all the talking to the hardware is done through the DAC. The DAC sets the current and voltage limit, and the ADC reads it back. That's the interaction with the actual power supply circuit itself. Now, the way you create the front end and all that is entirely up to you, but mine's just an example of that. And if you want to use it and build upon that, you're more than welcome to, because this is all open source. And yeah, so that's where I'm going to leave that for now. But yeah, like I said, all the rest is supplemental. Yeah, thanks for watching. Like I said before, I hope this is helpful to anyone. It's not the most accurate, but it's you know, it's got room for improvement. It's a basic platform for people to build upon, and when I get the CAN bus communication working with it linking to the other units, then that'll be good. And I am starting to learn Java, so it should be finding a way of making a front end so we can communicate with the power supply. And if you daisy chain them through the CAN bus, it should be able to control more than one power supply just through the one USB connection doing that. Who knows how many we could add, but you know, I am thinking of designing some other equipment like a bit of glitter on there then. The dummy load, eventually I may even do a series on that. I don't think so, it's just a quick one, but that will be CAN bus enabled eventually when I get around to doing that. And hopefully the software design, we can do all that, you know, lots of test and measurements through the different equipment all daisy chained together on a CAN bus. But that's my aim. I have daisy chained equipment on a CAN bus before, so I'm quite used to that, so I've no problems with that. But yeah, that's plans for the future. So yeah, so more videos to come as supplemental, and I will eventually finish the teardown on that satellite receiver, because I do intend to build another power supply in that box as well, so I can test the daisy chaining. But yeah, so that's that for now, and please like and subscribe if you haven't already done so, and I'll see you next time. Okay, goodbye.